Hello students, today we are going to talk about spectrum. But before starting this lecture, make sure to like and subscribe to our channel. Spectrum is defined as an arrangement of different EM radiations, is increasing order of their wavelengths or decreasing order of frequency. The electromagnetic spectrum is the range of all types of electromagnetic radiation, which are waves of electric and magnetic fields that travel through space. Different regions of the spectrum are identified by different names. Some examples are: first, radio frequency region around 10 raised to the power 6 Hz, used for broadcasting. Second, microwave region around 10 raised to the power 10 Hz, used for radar. Third, infrared region around 10 raised to the power 13 Hz, used for heating. Fourth, ultraviolet region around 10 raised to the power 16 Hz, a component of sun's radiation. Fifth, X-ray region around 10 raised to the power 18 Hz, used for medical imaging. Sixth, gamma rays region around 10 raised to the power 20 Hz, used for cancer treatment. The small portion around 10 raised to the power 15 Hz is what is ordinarily called visible light. The wavelength of the visible light is around 400 to 750 nanometers. Now, we will talk about the classification of spectrum. There are 4 types of spectrum. First, continuous spectrum. Second, discontinuous spectrum. Third, emission spectrum. And fourth, absorption spectrum. First, we will talk about continuous spectrum. A continuous spectrum exhibits a smooth and unbroken distributions of wavelengths or frequencies. Characteristics of continuous spectrum. First, no distinct gaps or lines interrupt the range of colors or wavelength. Second, all the colors blend in each other seamlessly from one color to the other. Second, discontinuous spectrum. A discontinuous spectrum consists of separate, distinct lines or bands of color. Unlike a continuous spectrum, it does not exhibit a smooth, unbroken distributions of wavelengths. Characteristics of discontinuous spectrum. First, features many distinct lines of color, separated by dark areas. Second, each line corresponds to a specific frequency and wavelength. Third, emission spectrum. An emission spectrum is a spectrum of the electromagnetic radiation emitted by a source. When atoms or molecules absorb energy, electrons within them are excited to higher energy levels. As these electrons return to their original or lower energy states, they emit energy in the form of light. The emission spectrum represents this light, which is specific to the substance emitting it and consists of separated lines at particular wavelengths. These wavelengths appear as bright lines on a dark background. Fourth, absorption spectrum. An absorption spectrum is a spectrum that shows the wavelengths of light absorbed by a substance. When light passes through or is emitted by a substance, certain wavelengths are absorbed by the atoms or molecules within the substance. This absorption corresponds to specific energy levels and appears as dark lines or bands in AC's continuous spectrum. That's it for today's video. Until next time, stay safe.